Welcome to this e-lecture, which will be about correlation analysis and the most used correlation measure, Pearsons R. But what are correlation measures? Well, they are standardized measures of how strong the relationship is between two variables. And they are zero when there is no connection between the variables, and 1 or minus 1 when the correlation between the variables is perfect. And we use them for variables at the ordinal level or higher level of measurement. And a positive sign is when the correlation is positive, and negative sign when the correlation is negative. And below you find the illustration where minus 1, that's when it's a perfect negative correlation, and 1 perfect positive, and 0 when there is no correlation at all. Pearsons R specifies how strong a linear correlation is between two variables and whether the relationship between them is positive or negative. And again, if Pearsons R is minus 1, then it's perfect perfect negative correlation. If it's 0, it's no correlation, and 1 is a strong, very strong perfect positive correlation. And then you have you have values all in between minus 1 and 1. And we're going to look at some examples later on. Other interpretations of Pearsons R are, for example, when there is a negative correlation, the red boxes here, then you have observation with below mean on x and above mean on y. Or above mean on x and below mean on y. So it's really when you have a negative correlation, a high value on the one variable goes together with a low value on the other. Then you have a negative correlation. So high values on one variable goes together with low values on the other variable. Then you have negative correlations. Whereas the blue boxes, observation below mean on x and below mean on y, or observations above mean on x and above mean on y, then you have that high values go together with high values, or low values go together with low values on the variables. Then you have a positive correlation. And let's look at this. Here we have different spreadsheets or different scatter plots. And as you can see, here there is a quite strong positive correlation. We can almost see that there is a line going through here, a positive correlation, that high values on the one variable goes together with high values on the other variable, and low values goes together with low values. So it's a positive correlation. Pearsons are 0.62, which is quite strong positive correlation. Here you have a perfect negative correlation. It's minus 1. So high value on the one variable goes together with low values on the other, and high value on this variable goes together with low on the other one. So it's perfect. It's a perfect negative correlation. Here you have somewhat negative correlation also, but it's more fuzzy. It's not so strong, but one can see that there's at least a negative trend in the scatter plot. And also in this one, there's here the dots are more clustered together, and it's almost a quite perfect negative correlation. Where here it's almost a perfect positive correlation, 0.87, and it's a strong positive correlation. And in this one we have there's a total spread, so it's really there's almost no correlation at all. Let's look at the correlation between life expectancy and general government expenditures of health as percentages of total expenditures on health for countries. And as we can see, there is a somewhat positive correlation. Pearsons R is 0.42, and it's significant. So in countries where the government share of health expenditures are higher, there's also a tendency to be a higher life expectancy. So there's a positive correlation. And And we can also put in the mean on the government's share of health expenditures, which is 59.4%. If you have x with a bar over it, that means the mean on the x variable, whereas the mean on life expectancy is 70 years. So the y with the bar over it is the mean on the y variable. But how are we going to interpret these correlation measures? Well, Cohen and Holliday has made some guidelines, but they must be considered as a rule of thumb because there are no consensus about these guidelines. 0.19 and below, they say is a very low correlation. 0.20 to 0.39 is low correlation. 0.40 to 0.69 is a modest correlation. 0.70 to 0.89 is a high correlation, and 0.90 to 1 is a very high correlation. One should say, well, I said there's no consensus about these guidelines, but really one has to consider what kind of data one has, and if municipalities and countries, for example, are much more equal, or there is less variation among them than there is among individuals. So I would say that for on the individual level, quite low correlations, 0.0 to 0.39 can be quite strong at the individual level, but at the municipality level or among countries, you would expect higher correlations before you consider them to be strong. So it's really one has to consider what kind of data one has. But usually we work with individual data, and I would say that actually these rule of thumbs are a bit strict, but they are totally okay to use. And hypothesis, Pearsons is also hypothesis testing. We are always testing the null hypothesis, so no association or no correlation. So our null hypothesis is that there is no association between the variables in the population, that the correlation is actually 0. And if the null hypothesis is correct, the observed association or correlation is due to sampling error and does not reflect the real association correlation in the population. If the risk of getting the sample association correlation, given that the null hypothesis is correct, is lower than the chosen level of significance, usually then 5%, it's rejected. And in our case, we can see that the p-value is much lower than 5%. So there's a significant correlation between health expenditures and life expectancy is definitely different from 0, and I mean it's very, very unlikely that H0 or the null hypothesis is true. So we reject the null hypothesis and keep our alternative hypothesis, saying that the correlation is different from 0. So that was the e-lecture about correlation analysis and Pearsons R. Thank you so much.